All right, welcome back to Youth Code Jam's online bits and bytes lesson. We're up to lesson 10, and today we will be making a rock, paper, scissors game using Java. If you remember, last Wednesday we posted an intro to Java video, so if you haven't done that one, you might want to go back and take a look at it. It will get you familiar with the online integrated development environment or IDE we're going to use, and it will give you some introductory to how the code looks and works and all that stuff in Java, because it's pretty different from our block coding that we've done in Scratch and different from what we did with Kano. So just a reminder, we upload new lessons Mondays and Wednesdays. They're supposed to go live at 8 a.m. If they ever don't, write us either on social media or send us an email and let us know so that we can get those up and running. And then we are still holding Q&A sessions at 4 p.m. on Tuesdays and Thursdays. You'll have to go online to register for those, and you can do those in two ways. You can go directly to this link and go to, so it's bit.ly/YCJ virtual lesson QA, and sign up for all the Tuesday ones, one Tuesday, or all the Thursday, or one Thursday. You can mix and match them. You will get invite emails before each one, so you don't have to hold on to the email or anything like that. Whatever you sign up for, you will get an email with the link to the Zoom meeting every time. Another way you can sign up is you can go directly through our website. So yep, there's the fun blackboard for school. So you can go to youthcodejam.org, and under our Jam at Home tab, you can go to Bits and Bytes, and this is our landing page for everything that we're doing with these online videos. So the little introductory with the schedule here about what we're doing and what days they're on. At the very top underneath that, we'll have the most recent lessons. So on Wednesday morning, this will change to lesson 10. And then we'll have what grades it's best suited for. Now, just a reminder, these are recommendations. These grades that we post on there are about what we think the skill level of the students are best suited for. So this one's really easy, and it will be probably too easy for students older than second grade, but it's a good starting project if they are just getting used to Scratch. But we have other ones that might say 6 through 12, and maybe your fifth grader has done coding or is really good with typing, and they want to do like today's activity, they want to try out Java. We definitely encourage that, and if they have problems, they should sign up for those Q&A sessions so that we can help them out. The grades are not only these students can do them, these are who we think will be the most successful or be able to do them without too much trouble. But if they have more experience or they are just adventurous and want to try it out, we definitely encourage that too. You never know, they might really like the typing as opposed to the block coding. So just because those grades are there, they shouldn't limit themselves to not doing it if they're too young. If they're a little older, they can probably definitely do them. They just might go through them really fast and be bored. So that's why we have those grades there. And then you'll notice we try and put what devices these things will work with. Technically, everything we do will work with a mobile device. But once you get to the phone, you really have to be, I've seen students use a phone for Scratch, and I've seen people my age use a phone for actual coding with text, like with Java or C. It just depends on your skill level and your patience, because sometimes working on the phone, you do have to go through a browser for everything. There aren't apps for these things, for the sites that we're using. So it doesn't always translate well. Sometimes it's harder to move things. So if you aren't very patient or your student doesn't have a lot of patience for things getting stuck, we're going to recommend sticking to a desktop, a laptop. Chromebooks are good. I'm pretty sure everything we're doing sticks with Chromebooks. And if you came to one of our build events, you might have a PyTalk. Tablets are still pretty good. The typing part, if you don't have a keyboard, might be a little tedious, but if you do have a keyboard extension for your tablet, a physical keyboard, then they'll be pretty good, especially for our Java and Python. There's a lot, and even the Kano art, really, there's a lot of typing. So even if you're still learning to type, having that physical keyboard there as opposed to the pop-up one on the tablet or the smartphone might be easier for you to work with. So this will all update after each Q&A. So the one for this lesson that we're doing, the rock, paper, scissors, will be on Thursday, April 16th at 4 p.m. And then you guys can just click this registration button and it'll launch you to our active page. And you can sign up for, our lessons will look like this. So lesson number 9, it will have the activity name and then Q&A and the date. So you'll just look for the one you want to go to, or when you go to sign up, you can sign up for all of them. Something else that launched this week was our inaugural virtual code jam. So this is our very first online code jam that we're doing. So if you go to wecanjam.org, you can find out some more information. Workshop started today. Everything is free, but you do need to register. So there will be live sessions with these workshops 1 to 2 times a day. There looks like they tried to stick to 1 a day or maybe 2. So like tomorrow, or I guess earlier this week, Monday, we had one on GitHub. On Tuesday, there's one on Fresh Paint and one on an intro to Scratch, which at this point, if you watch these videos, you'll be an expert at it. And then on Wednesday, so later today when this video goes live, there's one on Paint 3D. So that's week 1. And then I believe week 2, yep, this will all be, I don't know. So this is week 1 continued actually down here. So there's lots of different things you guys can do. And you just have to register and then choose which ones you want to go to. And then the whole point of this is to kind of give you some skills so that you can participate in a challenge or multiple challenges. So what these are you're finding a problem in the real world and coming up with a solution for it using your tech skills and offline skills. So these are some ideas that you can do, or you can come up with your own. So the goal is that you work on this either on your own or with a group or with your family, and then you submit it by April 24th, and you'll be eligible to win lots of prizes. So I know we have some cool tech stuff. I think there's some Microsoft game. I'll have to check the listing. We're getting that up, but there's lots of cool things that you guys can win. And then there's also, of course, your placements. So best in class, most creative, different kinds of categories in addition to the prizes. So we think it'll be really fun. And if you're looking for something else to do that's more coding based and not quite as school based, this is a good one. So here's the schedule on the homepage. Registration is open. It will remain open till the 24th when submissions are due. So you have until then to register. Definitely recommend registering early so that you can get access to the workshops and other help sessions. Okay, so I think that's all our housekeeping. Oh, one more thing. So on our, too many windows. So on our Youth Code Jam page, we have the virtual learning hub, and this will direct you to anything. So this will direct you back to that We Can Jam page. This will direct you to the bits and bytes where everything is. We have virtual recess, which we're putting online brain breaks. So these are actually, I said online, these are offline activities that you can download on Monday. Sorry. This is what happens when you live at home and never leave. You don't know what day it is. So we post them, a new one every Monday in a different category. So there's coding, maker, family, and logic. And what these are just different. They're all offline, so you don't need to have a computer or anything like that. And you can just go through. We are also posting some on social media if you follow us. And as you can see, that whatever you make, whatever you end up doing, we would love to see it. So just go online and tag us. We're on Facebook, Twitter, Instagram, and YouTube. And just tag us or tag your project with We Can Jam so that we can see what you guys are doing with these and how you're liking them. And then the last thing, we're no longer going to have the bit.ly links for the downloaded files. They're all going to be downloaded from this Bits and Bytes page. So if you scroll down under the video, you'll see it downloads, and then you'll have the listing of what sheets, activity sheets are available for the current lesson. And then they'll stay linked to the lesson. So for our old ones, they'll appear here too. So anytime you want to go back and look at something, or if you lose it, everything's on this page for these lessons, all right? So now, for real, let's get started. So like I said, we're not doing the bit.ly link anymore, so I have already downloaded the activity sheet Might even be open. Yep. So we're going to do rock, paper, scissors. So if you've noticed up here, we have these circles, and the ones that are filled in indicate the difficulty level. So this one's about probably intermediate, upper level intermediate for students. Just like last week, we're going to be using the Replit IDE to code in the Java. So a quick overview. This is for intermediate level coders who either have some typing experience or are patient typers if they're still getting used to it. So you do have to understand the syntax or the rules of the structure and the commands of Java. So we did go over some of those in last week's lesson, and I will go over that. So if you watched last week's Java lesson, you'll remember that I asked you to figure out how to ask the user for input. Today we're going to learn that. So if you couldn't figure it out, today we're going to see how that's done. And I'm going to refer to the sheet a lot because even though I work with Java, you get to the point where you just do things and you can't always remember the explanations behind them. And I really want to make sure that you're getting that knowledge. So I'm going to keep this up off to the side here and go to Replit languages. So auto-populated for me, but you'll just type in this URL into your address bar, hit enter. And so this one always has like a default program once it loads. So we will delete that again. We'll delete this, just this part, not the whole thing. I'm going to leave some of it, but we're going to delete the system out, the hello part. And then on step one, we're going to import two classes. So the classes are, well, everything in Java is pretty much a class. You have to have it in a class for it to exist. So normally whatever's in a package is related to what it does. Java has predefined or pre-created functions. You might think of them as libraries, but they're usually the kind we'll be using today are in the utility package. These give us these pre-programmed utilities like asking for input or printing to the screen, or you'll see here we're going to be using a random number. So that code is, some of it's really complicated to make, sometimes it's really easy, but it already exists, so we don't have to go and recreate our own. Otherwise, projects would be massive if you had to go recreate the scanner code all by yourself for class instead of just being able to import it. So we're going to click into our workspace here, right where it says class, and I'm going to hit enter twice. And the first time I'm going to import, we're going to do Java util scanner. And remember that capitalization and lowercase is very important. So import is a keyword. It's telling it we're going to go get a class from somewhere else. This is the path to get to that scanner, or the name to get to the scanner file. So it's going to go to Java. It's going to look in the utilities folder, and then it's going to grab the scanner. And then at the very end, we add the semicolon so that it knows it's reached the end of the line. If you don't, it might give us an error here. Yeah, so you see the reg squiggly lines like under a Word document that's typed wrong. So we're getting syntax error on token scanner, semicolon expected after this token. So for once, this error is very clear. It's telling us you need to have a semicolon here. This looks like it's the end of the line. Okay. So another thing you can do, we'll get to this, we're going to import Java utility random, and this will give us the utility to randomly create something or to draw something. So a lot of times you might have to generate a random number, and this will do that for you. So another thing you can sometimes do, so this is very specific. It's saying we're only going to use these two classes in addition to our code. And that's pretty good because you're limiting the overhead or the memory that you need in your space. Sometimes in your projects, you're going to have 10, 20 import statements, which is what I do right now because I'm doing a project that has an application to it, whereas this one, we're just doing the back end kind of working back end stuff. You're just doing code. You don't have that user interface like any program you open. I don't really have a game on here, but anything you open where we have that user experience where you don't see the code and you can click through with buttons or type or whatever, that will have a lot more classes in it. So sometimes it's easier to just do an import statement in java.util, and then you do the asterisk with a shift on your 8 key. And what this does is it's going to grab, you actually need a period right before that. So it's going to grab everything else in this utility folder and make it available to us. We don't have to worry about having to keep adding import statements. The downside to that is you could put a lot of overhead on your program and it would take up more space and it might run slower. So it just depends on how much you're using and what your standards are for either your class or your bus. Okay, so going on to step 2, we're going to create a public class for your program. You would do this if you erase this. You're going to, well, actually, we're going to just adjust it, looks like. So we're going to make it a public class. So public means that it's available to everyone. Any program that's looking at it can go see it. Private would mean that no one else can see it. It's kind of confusing to explain. So private normally means that you can't change anything within it, and it can only be seen by subclasses of it. So if it's another top level class trying to talk to it, it's not going to be able to use the private class. So you should still have everything there. If you didn't, if you had to retype, you'll have public space class main, make sure your name is capitalized, open curly bracket, and then add your public static void, main string, square bracket, args, all that fun stuff. So if you know, or maybe you don't know, this public static void main is typically just referred to as the main method. And what this is that it's available to everything within our program. The static means it's instantialized. We've created an instance of it, so we don't have to create a class for it elsewhere. It already exists. Let's see if we have. So what this means is that it's just going to run. We don't have to do extra work to make it run. And every time you run a class in Java, it's going to look for this. So if you start trying to execute commands outside of a main method, your program's going to get cranky. It will shoot off lots of errors, and sometimes they're not as clear as what we saw for the missing semicolon. They can be very, very random. So if you go into upper level coding, Stack Overflow will become your best friend, because every problem you encounter has been encountered before by someone, just about. So there will be answers out there. All right, so moving on to step 3, we're going to create a method for the user input called getting input. So this is called a get method. So that's asking, or that you're getting a variable, you're getting a value to store or use. And sometimes that can just be hard coded in, but this time it's going to be user defined. So that's why we're using the scanner method. The scanner will read things in from the console or from wherever you ask. It can even be used to read things in from files. So whatever you ask to read things into. So underneath our static main, we're going to do public static int getting, int getting. We're gonna do camel case because that's proper syntax. You won't usually receive errors for this one. Why are we getting this? Okay, so because it's empty, it's giving me this warning. It will clear as we fill it out. So let's go over a couple more things. So public and public, that means the whole program can see it. Whatever we extend from it can see it. The static means that, so typically you would have, because it's object-oriented programming, you would have something called, I don't know, class A. And in class A, you would have the true, you would actually have like a getter and setter method there, and you would have all the variables passed down. And in this file, you would just instantiate an object of class A, which means everything that you need to do, you're setting the variables or setting your object variables, you would do in the main method. We're doing static so that we don't have to have that outside class. That keeps us from having to mess with all of that and keeps it all in one file. That's good for small projects like this and just getting started. But as you get more familiar, they'll start having your instructors or online activities that you do will start having you break things out into several classes or in different kinds of classes so that your program is more modularized than anything. So if you have to go fix something in class A, it'll proliferate down through the stream instead of having to go into every file and change it there. But that's more upper level than we're going to be getting into. I'm just trying to give you a little bit of background. All right, so inside, on step 4, inside our getting method, we're going to define, before I get started. So the reason I did this is there's something called camel case encoding. And what that is you do all lowercase, and then if you do a second word, the first letter is uppercase and then all lowercase again. So it looks like a camel hump. And that's pretty standard for creating method names or function names or variables. It's just a way to, normally in some languages, I think Java is one of them, if you start a variable name or a method name with a capitalization, it might get cranky because it's looking for a predefined or a pre-existing one. This is just the standard. You can do a lowercase. Sometimes that's harder for us to read. That uppercase letter of the second word or third word makes it easier for us as the human to process. The computer obviously doesn't need that uppercase. That is for us. All right, so back on 4, we're going to use the scanner method. So we're instantiating an object, a scanner object. So that's like what I was talking. Scanner is an outside class that we have imported in. So we are creating an object of it. So to do that, we're going to type scanner, because here scanner is our object type. And I think in the example, they use keyboard. So this is our object name that we're using within this program. You could do anything you want. Typically, a lot of people just do scanner or scanner S to save time. Programmers are lazy, but we're going to use keyboard so that it's clear that our information is coming from the keyboard. Sometimes if you're reading from a file, you might put file name or something like that. And then we're going to do new, and this is how we instantiate it. So we're going to do new scanner, open parentheses, system in. So if you remember when we did when we loaded the page, whichever you saw, we had system.out.println. So that was telling it to print to the console, which is over here. So we'll see it here. If we were telling it to print to a file or print to a window, that would look differently. But we're telling it to print in the console. And here we're telling scanner to pull from the console. So we'll get a chance to type in here and give it information, and the program will pull that information in through the scanner and store it in keyboard. Okay. And then the next thing we're going to do is we're going to create another variable. So this is object variable is not the best way to describe this. This is an instance of an object. That object is the scanner. The scanner is a class. And when we instantiate a class, we get an object. So that keyboard has all kinds of variables and properties that you can set to it by instantiating it here. Next, we're going to create a normal variable called user num and set it to 0. So in Java, more so than C, you really want to, this part right here is declaring. So if you just did int number, you've declared your variable. And for the most part, that's fine. But Java is really particular in that it likes you to instantiate it too. And instantiate really means to give it a variable. So here we're setting int to 0. We're going to start at 0 for whatever we're doing. Let's see. So this little green line we have going under here, it's telling us this is a resource leak because keyboard is never closed. So at the very end, when we're done playing the game, we're going to close our keyboard. I think this might be a new development. I don't remember it from the first time I did Java, but it's also been 3 years. So what a resource leak could be is that we're not keeping all of our data secure or in one place. So it could go somewhere we don't want it to go, or it could cause problems later. So we just don't want it to become a random number somewhere or not be there where we need it to be. So we will close that later. Sometimes you'll create a variable and it will get squiggly lines underneath it and it will say variables not used. Well, I just created it, so I haven't used it yet. So declaring and instantiating is not the same as using. So that's another thing you might see. So I'm going to hit enter a couple times, and on step 5, we're going to print out some instructions for the user using the system.out.print. Okay, so we're going to copy all of this in the little picture over here. So I can see that. I would probably recommend looking at my screen while I type, or pausing so that you guys can type. But let's look what we have going in here. So we're going to tell the user, we're going to ask them, would you like to use rock 0, paper 1, or scissors 2? And what we're trying to tell them with this is that they're going to type a 0 for rock, a paper for 1, or 2 for scissors. And that number is going to be stored in our user num variable. Okay? And then this next line, user num equals keyboard next int, that's going to that's what's going to pull in that number. So this line's going to print out, the user will type one of those numbers, and then the keyboard next int is going to grab that integer, that number from the console, and store it in user number. And then we were going to return whatever that number is to our main method up here. So we're going to return it to another int number or something else. We're not quite there yet, but let's go ahead and finish up our getting input statement. So you're going to use something else that you guys should be paying attention to that I didn't mention are indents. So an indent is usually equivalent to 4 spaces with the keyboard. I've been hitting the tab key to create these. A lot of IDEs like this will auto indent for you if you're inside a statement like this. So you may have noticed that. But it's very important to stay lined up and within these indents, mostly just so your code looks clean. I don't think in Java the compiler gets too cranky if your indents aren't aligned, as long as everything's inside the brackets correctly. It'll normally handle it, but go ahead and practice keeping your indents correct. Right, so would you like to use rock square bracket 0, comma, paper square bracket 1, comma, or scissors square bracket 2. And we're going to end it with a colon and a space, so that whatever the user enters is not right up next to that colon. They're right there. And then outside, see, I clicked outside of my closing parentheses, and I'm going to hit semicolon so that the program and I both know that we've reached the end of the line. Okay, and now we're going to use user num equals keyboard next int. So you'll see as you type, and this is most IDs that I've seen, suggestions will pop up for you to just kind of autofill what's there. You can do that if you're new to typing, but I do recommend that you practice typing with this. It's a good one. It gets your fingers used to everything, and it helps you remember the keywords more and how things work. So if you see, I came here, I hit enter after the end of that line, and then it already has me indented correctly. So I'm going to do return now. And this will return us to the main method, which called this function. So we haven't written that yet, but we're going to create something in here that's going to call down to here in order to get this information. I'm just going to close that up. So I believe that's what we're doing next. So let's look at step 7. Step 7. All right, so we're using numbers 0, 1, and 2 to stand in for rock, paper, scissors. So the user num is our variable. And these are kind of like our pseudo values. We could use a string. It's a little bit more complicated. It's easier to sometimes translate real world objects into an integer, to have it have even like an extra stand-in for it. So you're having a variable for a variable almost. So we have those, and then the computer, well, we can't tell the computer what to do, otherwise we would win all the time. So the computer is going to have to generate or come up with a random response in that range of 0 to 2. So in our main method, we're going to do a few things. We're going to declare. Well, first up here, we're going to call our user. We're going to call the getting input to store a user number. And then we're going to declare and instantiate a new random object called comp, short for computer. And then we're going to declare and instantiate by using the method next in to get that number. So we're doing a lot, but it'll be pretty simple. Okay, so inside our main method, did I do that right? Yes, we haven't typed anything in our main method, did we? Oh, it looks like we did. I missed a step. That's okay. We're going to type all of that now. So in our main method, we're going to create our, or I got confused, hold on. Okay, so int number should be in our main method. So int, and then user num equals 0. So we instantiated that one there. And then underneath here, we're going to use user num and then call getting input. Okay, so the reason this is an empty an empty opening and closing parentheses is we're not passing anything to this method. We're just returning an integer. So now in this method, I'm going to delete this declaration here. I'm going to delete, it's line 12 for me. We don't need that one there. Did we? Yes, my bad. No, that one stays. Okay, so that one stays there. We're all good because you have to declare a local variable in order to store it and pass it back up. So these don't have to be the same name. We could have done unum. It doesn't matter because this is local, so it only exists within this method. And then this user number up here, user num, it only exists up here. So there it is. The value of the local variable user num is not used. Well, technically, yes it is, but it's being cranky. Okay, and then we're going to declare and instantiate a random object. If we can type and spell. New random. Okay. So we've completed step 6. All right, now on step 7, we're going to create another integer to store the computer's choice. So comp num equals comp next int. So we're hard coding 3 for some reason. Add the line, just not inclusive. All right, okay. So what we're doing there is we're passing the end of our range. So we're telling it to go from 0 to 3. And the reason we're telling it to go to 3 is because that last number, so 3 will not be included with our choices. It's only going to choose between 0, 1, and 2. But we do 3 so that the 2 is included. And now we're going to print out a message that says system out print ln. If you remember from last week, the ln at the end of print puts everything on a new line so that it doesn't run into whatever was printed out before it. If you just did print, you'd have to add a new line character to the end of your sentence, so this just saves time and is easier. Welcome to the RockPaper Scissors. If any of you are writing people, there are no commas in RockPaper Scissors. It's just like that. It's kind of weird. Okay, so let's check our code and see if it matches. So one thing you can do as you type is that you can press run and see what's going to happen in your code, test it out. I think mine's still thinking there. Okay, so we have a little bit of a problem. Keyboard matches. So what's this say? Next int symbol. Variable name user num. Because I changed it to u in down here, it caused an error. So now we're going to do this one. All right, so now I'm going to run it again, see if there's any other errors that might need to be fixed. This is called debugging. So I'm going to do 1 for paper and then hit enter. Okay, so welcome to the rock, paper, scissors game. So that's all we've written, so that's all it's done. So yeah, debugging is going through your code and seeing what errors happen. So what happened here was that was a runtime error. This would also display syntax errors if we did not fix them over here, but that's why it's important to pay attention to those little squiggly lines. You can fix a lot before you run, which can save you a lot of headaches. But sometimes the squiggly lines, they may offer a fix, and that's still not the fix you need, which means that what you're trying to do isn't right. You need to approach it in a different way. Okay, so now that we have all of our variables, we're going to use some if statements to print the results of our matches between us and the computer. So we have, for the computer to win, the user has rock and the computer has paper. For the user, or the user has paper and the computer has scissors, or the user has scissors and the computer has rock. So those are the cases that we will be using. So in our main, underneath our welcome message, we're going to type in this code right here. And this is going to be a if-else statement. So if user num is equal, so when we're doing comparisons, this is a comparison operation. To say is equals is a double equal sign. If you just do 1, that is telling it that username is 0, and your code is not going to, it might execute, it might actually print something, but it's not going to check correctly. It's just going to say, okay, username is 0. And I'll do what if I can do anything, I'll do what I can if it's 0. If not, then I'm just going to not do anything, or I might send out an error. You normally don't get a syntax error or anything for that kind of mistake, and it will show up, and it might not even show up as a runtime error depending on how it works in your code, because that is not an illegal operation. This is allowed to happen, right? We did it up here. But down here, we meant to say equals. We didn't mean to assign it the value 0. So that's a common mistake that we all make a lot, and it causes a lot of headaches because it's a really hard one to go back and find. And then we're going to set the computer number equal to 1. And we're going to have a compound if statement. So what that means is that this is just 1. Well, actually, you could just have that, right? And then do an else if down here. And you could just check one condition at a time. So we're already doing a compound condition by doing these two together, but we're actually going to go back to before user num and insert an open parentheses, and then come back here and insert a second closing parentheses. So I actually had to type 1, hit a space, and type another, because we're going to be comparing 3 different cases, which each have 2 conditions that must be true. So in the first case, the user number has to be equal to 0, and the computer number has to be equal to 1. And what this is all going to display is that the user, have lost. But we have 2 more times where you, the loser, can lose the game. So we're going to use the double pipe, and to get that, you're going to hit your shift key, and then the key directly above your enter or return key on your keyboard should be a little straight line. You're going to hit that twice, and that's going to be our OR operator. So and is the double ampersand there. That's located above your 7. You get that by hitting the shift key and typing 7 twice. And again, this pipe key is on your keyboard above your return or enter key on the right side of the keyboard. And you just hit shift and then hit that key twice, and you'll get that one. And then we're going to do open parentheses, and user num is equal to 1, and computer, oops, we didn't need that, computer num is equal to 2. So sometimes you'll notice I'll add spaces around my operator or I won't. It doesn't matter in Java. It will accept it either way. In some languages or scripting, it does matter. In this case, it's fine. It's whatever works for you. And then finally, user num equals 2. Oops. And computer num is equal to 0. Okay, so that's just our condition. We're now going to use an open curly bracket to write what happens. And in this case, we're going to have a system.out.println, open parentheses, double quote, you lose, and it looks like we make a frowny face, and then come to the outside of that parentheses and do a semicolon. So real quick, this is the statement to execute. So this is where we'll run something. The compiler, the interpreter are going to read this and they're going to do something with it. We don't do a semicolon at the end of a condition because we're saying if any of this is true, then come in here and execute this. So you're not really executing the same way here. You're just comparing. So there's not going to be any output or something's not going to change. We're not that's what it is. We're not changing anything in our condition. We're just checking something. And then here we'll change, or you can print out a message or something like that. All right, so that's our first if one. We're now going to do one for you win. And it's pretty much going to be the opposite cases, right? Because this one is if you, the user, get to win. So if double open parentheses, and in this IDE, you'll notice that anytime we do an open parentheses, an open curly bracket, an open square bracket, it auto completes that pairing for us, and then we can type in between them. So I'm going to type user num equals 0 and computer comp num equals 2, and then click outside of that one, use my OR operator, do another open close parentheses, user num is equal to 1, and comp num is equal to 0. Click outside of that, do an OR operator, open close parentheses, user num is equal to 2, and computer comp num is equal to 1. I'm using my key. You can use your mouse to click to the outside. I'm using my right arrow key. Open curly bracket, enter, system out println, double quotes. Remember, our strings always go in double quotes. You win. I don't know what, you didn't get a happy face here. I'm gonna add one. You should get a happy face if you get a frowny face. Semicolon, whoops, get rid of the J. Okay, set the parameters for tie when the user and computer have the same number. So, did we do an else if? Oh, this was a giant else if statement. So click back to the top of this second if and backspace till it's next to this curly bracket, and then type else space. And then finally, else will not have a condition. So for this one, if we fail, if none of these are true and none of these are true, then we had a tie. And you don't technically have to do this condition. You could just fall through to this, but on this example we did. So we're going to do else if user num equals computer num. Inside of here, we're going to type in system.out.println. It's a tie. Okay, so the reason we have all this is because there's lots of cases to consider. And sometimes in programming, you just want to be very specific so that you catch it, especially when you're taking user input, because users could introduce all kinds of things. So what we don't have is if the user types in a 3. We don't have anything to handle that. And what's probably going to happen is that we would get an error saying invalid input because we didn't accept it. You can write code to handle that and print out a message to the user saying, hey, we can't take that, try again. Whereas if we were to do that on a run through here, it would probably crash the program. Okay, so we're gonna run this and see what is and is not working. I mean, it could all be working. Yours might work. Mine might have some few typos to go back and check. All right, let's do paper again. I lost. All right, so you only get one try. You could try to build this so that it loops through, I don't know, 5 times. You get 5 games, and then you say whoever won the most is the ultimate winner. So you would have to have a counter variable to keep track of who won. So let's see what happens when I do 3. So it accepted that. It said I can't do anything with it, so I'm exiting the program. So you didn't actually get an error, but it realized it can't do anything with this, so it's just going to end at the end of our method. It's not going to continue to the if statement. None of those conditions of it being a 3 are accounted for. But yeah, so one thing you could do is you could have this run in a loop so that it asks you to do everything 5 times and keep track of who wins each time, and then at the end print the message of the ultimate winner is the computer, or the ultimate winner is the user. That sounds really complicated. It's not. You can use the internet to look up how to work with loops if you're interested. You could reverse the game. So you could reverse under what conditions do you win. So maybe paper beats scissors and scissors beat rock. So everything would be backwards, and you could keep count from there. You could have the program print the computer's choice when it tells you who won or lost. And then in tie conditions, you could do you could do a smaller loop version where it has you play again. So those are some things you can do. They're not too hard. If you need help, you can come to the Q&A meeting on Thursday. We can definitely figure that out together if you get stuck on one, or you can look up how to do it and show off what you do there. Again, you can just go to our website at usecodejam.org, go to the Bits and Bytes page under the Jam at Home tag and that column, and everything will be up here. And so the big green button is how you register. But yeah, I hope that you're liking these typing ones. We're not going to do a Java one again. The next one we do with typing is going to be Python. So it doesn't have as much with the syntax and the semicolons and everything. There's still some stuff, but it's a little less. So some people might find that a little easier to get started with. But I hope that our older students who were looking for things to do are enjoying these. And maybe getting inspired to kind of come up with their own programs. So I look forward to seeing you guys all at the Q&A. Have a great day.